Okay, so we're going to do some complex analysis, and we'll look for the Laurent series about 3 for 9 over z times z minus 3. And we're looking for it on the set where the modulus of z minus 3 is greater than 3. Okay, so as this is greater than 3, we can link this with a famous divergent series. So we know there's a divergent series for modulus of z greater than 1, which is 1 over 1 plus z, and the summing series of this yields us any 0 to infinity. Now this is an alternating series, so it gets the minus 1 to the n and then z to the n. Okay, and that's true for modulus of z greater than 1. So how are we going to manipulate this into this, or vice versa? So if we take the 9 over z minus 3 and leaves us with 1 over z, we've got something similar here. So let's have a go. Let's have a go with that. So 9 over z minus 3 times z. Just write it this way round, and now I'm just going to break it apart. So that's 9 over z minus 3 times 1 over z. But we want a z plus 1, or a 1 plus z. So we need it in this format. So we can rewrite this. We could add 3 and subtract 3. So let's write that down. 9 over z minus 3 times 1 over z minus 3 plus 3. So now we've not changed the value of these terms at all yet. And we've got the 1 over z minus 3 here. So now what we're going to do, we've got z minus 3 plus 3, but we want 1 plus z. So what we could do is, if we multiply this by z minus 3 top and bottom, and then this z minus 3 we could divide on this side somehow. So let's just go for that. So first stage will give us 9 z minus 3, z minus 3, that's the top done by, and then this one here, we'll just square that, okay? And then we're still going to multiply by 1 over z minus 3 plus 3. Okay, so now this z minus 3 on the top, if we divide the top by z minus 3 and the bottom by z minus 3, then that will yield something different here. So let's just have a look at that. So 9, I'm still going to write the z minus 3, z minus 3 squared, and then 1 over z minus 3 plus 3. Okay. Now this z minus 3, I'm going to divide this with this. So this one here can divide by z minus 3. So that will give us 1. And I'll divide this by z minus 3. And this one by z minus 3. So this will give us a 1. That will give us the 1 that we're looking for. And then we've got a 3 over z minus 3. So let's just clean this up a little bit. So now we've got the 9, this becomes 1, so that just stays, z minus 3 squared, and then we're going to multiply that by 1 over 1 plus 3 over z minus 3. Okay, this is still the same as this, but now we've got the formula or a function looking like this kind of format. So if we just put that in the brackets here, then this in the brackets here, then maybe we can substitute this 3 over z minus 3 into our series, and then we can find our Laurent series. So as this is going to be divergent, we can manipulate this somehow. So let's just have a look at this. Let's see if we can get it in this format. So this 9 over z minus 3 squared, that will stay. and now we're going to multiply it by the summing series for this. So that will equal that. So then we're going to multiply that by the summing series from n is 0 to infinity. Now just go careful here. We've got the minus 1 over n. Okay, so that's good. And now we've got the 3 over z minus 3 for our z. So we'll just put that in there. And then that's going to be to the power of n. Okay, so now we've got something in this format here. So let's just see when we write these series what we get. So first of all, with the basic one first, when n is 0, this is 1 and this is 1, so we get a 1. When n is 1, we've got minus 1, so that's minus z to the power of 1, so that's just z. When n is 2, we've got positive, and then z squared. And then as this is an alternating series, we can see where this is going, and then so on and so on. Okay, now let's see if we can get this written out in this kind of format. So the minus 1 to the n, we know basically it's just this alternating. So we've now got, we still need the 9 over z minus 3 squared. Just make that a little bit up there, right. And now the summing series. So plug in n is 0, so that's a 1. And anything to the power of 0 here is also going to be 1. So then that's just going to be 1. And that's a simple positive 1. Now what about when n is 1? It's going to be a minus. And then this to the power of 1 is 3 over z minus 3. Okay, just leave that in there like that. Okay, now what about when n is 2? This then becomes positive, and this becomes 3 squared, which is 9, and then z minus 3 just squared. Okay, we'll just do one more, because we'll see this is going to follow a pattern. So when n is 3, we have minus, and then 3 to the power of 3 is 27, and then z minus 3 is just going to be cubed. Okay, so we can see now, and this will just go on forever and ever, for up to infinity. So we can just we'll just close the brackets off anyway, and we can see that the series goes off to infinity. So now what we need to do is distribute this term here, just like the good old days, FOIL it along, and that will give us our Laurent series about 3 for this function. So let's just write that in now. 9 over z minus 3 squared times 1, so that's just going to yield the same. Okay, so now we've got a minus sign. So we've got minus 9 times 3, so that's minus 27. And then z minus 3 squared times z minus 3 is going to z minus 3 cubed. Okay, now this one, with this one, that's a positive, so that's going to be positive 81. Z minus 3 squared and squared, that's z minus 3 to the power of 4. And now we can see the pattern. Minus 27 times 9, well 27 times 9 is 243. And then z minus 3 to the 3 times z minus 3 to the 2 is just z minus 3 to the 5. Okay, so this will now just go on and on and on and on forever, and it will just yield our series to be minus 3 to z minus 3 and then n plus 2, and that will just go on forever and ever. Okay, so that's our Laurent series about 3 for this function. Now,